All right. Let me get some of this stuff out of here. Not a good way to start a video here. Sorry about that. Um, quick video. What is E? You see this on your calculators. It is essentially a number. We call it a transcendental number because it actually occurs, naturally in the from mathematical models. We use the model exponential growth. And so we'll take a look at that real quick here. And actually, we can define it like we do here two different ways in terms of a limit. Okay, so many applications with things growing exponentially or decaying exponentially in nature. The actual number is 2.718281 and it goes on and on and on. It's an irrational number that never ends, nor does it ever repeat. And there are mathematical proofs you can go through to do that, but just maybe a number you're more familiar with would be pi. Okay, and we just happen to use the Greek letter pi to denote that number, which is 3.14, which essentially is anytime you take the circumference of a circle and divide by the diameter, we get that ratio 3.14 and so on for pi. Well, the same thing happens here. Where the E comes from, why we're using E, it's actually in honor of the mathematician Euler, who was a German or Austrian mathematician, and his name begins with E. So we just do it in honor of him, or mathematicians, I guess, bestowed that upon him some point in history due to all the work that he did or contributed with working with functions. Okay, so just remember it's an irrational number like pi, and it's about 2.7182. If you just go to your calculator and hit e to the first power, you're going to get that. Now, here's just the expression, and this is what we mean by the limit here, as x is approaching plus infinity. I'm going to take this expression, which is 1 plus 1 over x, raised to the x power, and you can see if x is equal to 10, now 100, 1,000, and so forth, this expression becomes closer and closer to 2.7183. And notice I have here a million and 10 million put in there. And I'm only going to be able to, go out to so many or show so many decimal places here, but it's rounding already when I get up to, what is that? I guess that will be 100,000. Um, it starts rounding to 2.7183. Okay, so that would be right there. And then anything over that is going to round to the same thing for 4 decimal places. So that's where that comes from. Now, likewise, I could take this expression 1 plus x to the 1 over x and approach 0. And when I do that, notice I go from 0.1 to 0.01, 0.001, 1 to times 10 to the negative fourth, which would just again be another 0 added on there. Notice again, as I get closer and closer to 0 here, 1 times 10 to the negative 9, I get the 2.7183. So both of these expressions right here are going to be different ways of expressing or defining, I should say, the number E. Um, so we're going to see that we're going to have some applications coming up where we use this number E as a base. So remember, what would the graph look like for exponentials? Well, that number's greater than 1, so we're going to have a graph, and I don't have one. Well, I guess I can come over here to my Desmos, actually, and if I want to type y equals, and I just can type in the letter E for my keypad here and raise it to the x power, you can see that that's going to just be an exponential there, okay? And with a base greater than 1, right? So it goes through the 0.01 and it increases like that. And we have a horizontal asymptote in this direction of y equals 0, just like we said in the other video. We'll keep this in mind that logarithms are the inverse functions. We'll talk about logs here in another video, but we can use that as a base for a log function. And because we use these so often, instead of just writing out log x base e, typically we'll have a log base 5, base 2, base 1, and then it'd be any base greater than 0, okay? It's not equal to 1. And since we use e to the x so often, we have special notation. We'll just call this lnx, or natural log x, because again, we call this the natural number. Same thing over here. We have used 10 raised to the x so often in science and different, just our numbering system. And so we call these common logarithms. So if you don't see a base here for your log notation, again, I know we're not talking about logs right now, but just I'm trying to tie it together with this function y equal e to the x. We also have, just write log x, but really it's implying a base 10. So whenever you see this, it really means this. It's a log function with the base e. Whenever you see this, we really mean this. It's just base 10. It's just, these are just popular ways of writing these, or common ways of writing these. And so therefore, you'll notice you have that button on your calculator, just a log button or an ln button, if you will. So I just kind of wanted to show you how these is tied into the number e here. Okay, so I'm going to end this video here, and we will get back with some other ones. And if you watch this one, obviously you did if you're hearing me now, I hope it helped.